Last section, we made it to the end. We're on Chapter 10, Section 6, which is Learning Plan 512, and we're going to deal with applications. So, let's see how we do it. Remember, we're just going to review some of the properties that when you raise a number to the power, it's the same regardless of what those two exponents are if they are equal. And then the same is true with their logarithms. So, if you have 10 to the x equals 4, we could rewrite that as log x log 10 equals log of 4. So we took this 10 to the x, remember that x here is the same as x out front, but this part here is 1, so we have x equals the log of 4. So now we just press on our calculators the log of 4, and we get 0.60, so x equals 0.6021. You do this one. Oops, I'm sorry, I'll do this one. So here we have log base 5 x equals log of 20. Get the x all alone by dividing both sides by log of 5. So x equals log 20 divided by log 5. So we'll press log 20 divided by log 5, and we get x is 1.86. Now make sure that you close the parentheses, because your calculator comes up like this. Make sure after you enter the 20, you close parentheses before you press the divide by key. And I suppose we could check that by saying 5 to the 1.86, and we get 19.956, so it works out. This one, e to the 0.02x equals 192. We can rewrite that as ln e to the 0.02x equals ln 192. Put this out front, and we have 0.02x. ln of e is 1, so times 1 equals ln 192. Divide both sides by 0.02. 0.02, so x equals ln 192, close the parentheses, divided by 0.02, and we get 262.875. Try this one. Okay, so it's 0.12x ln e equals ln 10, because I took the 0.12x and put it out front. This part is 1, so we have 0.12x is ln 10, divide both sides by 0.12, and you get x is ln 10, close parentheses, divided by 0.12, oops, and you get 19.1882. All right, so when you have an exponential equation, get it into this form so that you can cancel those letters. As special cases, if both sides can be rewritten as exponentials with the same base, do so and set the exponents equal to 1. So let's look at solving some exponential equations here. Example 3. So we would have log base 3 of x plus 1 to the 5th is 3. We could rewrite that as a without the logs by saying x plus 1 is 3 to the third. X plus 1 is, sorry about that, 5 log base 3 of 3 is, let's see, how should we do this? I'm going to start over again. Let me erase this here. It's going down a track that wouldn't get me very far. Okay, so if we had x plus 1 to the fifth is 3 to the third. There we go. Because remember, that's the exponent and that's the base. Okay, so what can we do now? 3 to the third is 27. X plus 1 to the fifth is 27. So we could take the fifth root of both sides. Is the fifth root of 3 cubed. So we would have x plus 1 is 3 to the 3/5, or x equals negative 1 plus 3 to the 3/5, or we could have, I guess we could have left that as the fifth root of 3 cubed. Either way, we can't get it any simpler than that because it won't simplify anymore. You do this one. So we would have x plus 1 to the third is 5 squared, which is 25. Take the cube root of both sides. Cube root of 25. So we have x plus 1 is the cube root of 25. So x is negative 1 plus the cube root of 25, which you can't simplify. Well, you could write it as 5 to the 2/3, but that's not any simpler. Okay, here's a problem that's a little bit longer, and we remember the rule for addition is the same as multiplication. So we have log base 8 of 2x plus 5 over 3 equals log base 8 of 33, or 2x plus 5 over 3 equals 33. Multiply both sides by 3, you have 2x plus 5 is 99. Subtract 5 from both sides. 2x is 94. X is 47. Here we've got a subtraction problem, so you try this one. So you'd have log base 4 of 2x plus 13 over x plus 1 is log base 4 of 10. Now you got the same thing on each side, so you can say 2x plus 13 over x plus 1 is 10. Multiply both sides by x plus 1. You have 2x plus 13 equals 10x plus 10. Subtract 2x from both sides and subtract 10 from both sides. You get 8x is 3, so x is 3/8. You try this one. Nope, I'm sorry. I'll do this one. I didn't see that. So we have log of x times x plus 15 equals 2. What should we do now? So we would have, well, this would be x times x plus 15 is 10 to the second. And we just changed this log into an exponential form. X squared plus 15x minus 100 is 0, right? What two numbers multiplied equal 15 are 10 apart? Or, I'm sorry, 100 are 10 apart, 15 apart. I can't think of any. Might have to use the quadratic formula. Negative b plus or minus square root b squared, 15 squared minus 4 times 1 times 100, negative. So it's 225 plus 400, which is 625. That comes out evenly. Square root of 625 is 25. So negative 15 plus or minus 25 over 2. Negative 15 plus 25 is 10 over 2, which is 5. 5 and 20, why didn't I think of that? X plus 20, x minus 5 equals 0. My brain just wasn't working. X equals negative 20 or positive 5. Now, we can't have the log of a negative number, and so 20 can't work, and so our answer must just be 5. Okay, so we solve exponential equation or logarithmic equations by transforming them into a single logarithm, or using the property that if you have equal bases, then the logs are equal. Or you could just rewrite the logarithmic equation as an exponential equation. Here's an example that we deal with interest, and we use the formula A equals P parentheses 1 plus R over N to the N T. Find the value of $2,000 times 1 plus 4% compounded quarterly. Well, if it's 4% compounded quarterly, it's 1% per quarter, so 1 plus 0.01 to the 10 years has 40 quarters. So on our calculator, we would press 2,000 parentheses 1.01 close parentheses to the 40th, and we get $2,977.73. Oops, you do this one. Oops. Oh, I'm sorry, this is a classroom example. So your money would double if you would take 2p is p times 1 plus 0.004 over 2 to the 2t. Approximate the time that it would take to double your money. We would take 2 is 1.04 to the t so we would have log of 2 is t log of 1.04. Divide both sides by log 1.04. That will be our t. So we could press log of 2 divided by log of 1.04, and we get 17.67 years at 4%. There's a thing called the rule of 72. In other words, the interest rate times the number of years is going to be 17. 4 times 17, or 4 times 18 is 72. 17.67 is pretty close to 18 years. Continuously compounding, we use the formula A is PE to the RT. So if we have $2,000 at 5% compounded continuously for 10 years, it'd be E to the 0.05 times 10. So we would press on our calculator 2,000 times, now I have to press second function E to the 0.05 times 10, close parentheses, oops, and I get $3,297.44. And then how long would it take for the amount of money to double? We would have 2,000 equals 1,000 PE to the rate, I forgot what the rate was, 5%, 0.05 T. Okay, so let's take let's divide both sides by 1,000. We'd have 2 is E times E to the 0.05 T. Take ln of both sides. Ln of 2 equals ln E with 0.05 T out front. This is 1. So ln of 2 is 0.05 T. Divide both sides by 0.05. You get ln of 2, close parentheses, divided by 0.05, and we get 13.86 years, which is about right, because if you take 5 times 13.86, you get about 72, you get 69.3, so it's pretty close, 13.86. Okay, how about exponential growth and decay? One of the formulas says that the initial amount times e to the 0.0239 t. If the initial sampling is 12 grams, how many grams will be left after 35 years? So 12 times e to the negative 0.0239 times 35. So on our calculator, we'll press 12 times e to the negative 0.0239 times 35, close parentheses, and we get about 5 grams, 5.1987 grams. So what is its radioactive half-life? In other words, if we have y equals y0, e to the negative 0.0239 t, and y0 is going to be twice as big as y, then we will have 1 equals 2 e to the negative 0.0239 t. Divide both sides by 2. We have ln 1/2 is that 2 there cancels, is ln of e with a negative 0.0239 t in front. This is 1. Divide both sides by 0.0239 negative. we get t is, so let's press it, ln 0.5, close parentheses, divided by negative 0.0239, and we get 29 years.